Alright, so here's number 3. They gave you angles B, C, and side A. So the first thing we do is find angle A. Okay, because we don't have opposites, so we can't use the law of sines until we have opposites. So here's the work for A. I added these two, subtracted from 180, and you get this. Then you set up the law of sines. To find side B, you cross multiply, and you get this. Here's the setup for that for your calculator. For side C, again, you cross multiply. Use this ratio right here. So 8.4 times this divided by sine 66 to get C. And so here's the setup. Here's the answer. For number 7, first you have to figure out if you have, how many triangles you have, because this is the ambiguous case. Because we do have opposites, but we only have one angle, so that's the ambiguous case. Now, since this side is bigger than this side, that we know then we have one triangle. Okay, so set up the law of sine. So here it is. Since we're missing both of the C parts, we're going to go ahead and look for B first. And here's the setup for that one. Cross multiply. And this is going to give you a decimal because it's sine B. It's a ratio. To find angle B, you do the inverse sine, and this is what you get. To find angle C, you add B with A here and subtract from 180, so that gives you this. And so finally you look for side C. Again, using the law of sines, I'm going to use this ratio and this ratio, so you cross multiply, and this is the setup. Alright, number 8 is another ambiguous case. This one turns out to be two triangles, because when you find H, you get 2.59, and since this this is shorter than this, and that means that this could reach here and it could reach here, so it gives you two triangles. So I set up the chart, and so the first, let me walk you through the order in which I found the answers. So first, I set up the law of sines because I knew A and angle A, so that's going to give me B1. Cross multiply, and this is the setup right here. To find, this is going to give me the ratio. To find angle B, B1, I used inverse sine, and I got 3117. Now I know that these two angles right here are supplementary, so I did 180 minus 3117, that gave me 148.83. That's angle B2 from the second triangle. So now I'm going to find angle C1. So I take this angle B1, the one they gave me, add them together, subtract from 180. So that's going to give me 133.83. And I'll do the same thing for C2. I'll take 148.83, 15, add them together, which is here, subtract from 180, and that gives me 1617, okay, degrees. Okay, so now we're just missing side C1 and side C2. So here's the setup for C1. I use this ratio right here, and then C1 over sine of C1, cross multiply, and here's the setup, and that gives you 1384. For C2, again, I go back and I use the same ratio and make it equal to C2 over sine C2, which is right here. Cross multiply, and so you get this in the calculator. That's 5.38. Okay, number 10. Move this out a little bit. Number 10 is no triangle. Why? Because this is an obtuse angle and this side is shorter than this side, so it's not going to reach. So it's no triangle. And you're done with that one. Number 11 is a word problem. You have the picture in the handout, in the worksheet. And so the measurements in black are the ones that were given to you. This is what we're looking for. So this angle was not given, but we need it because that way we have opposites, because I have this measurement, so I need that angle. So here's how I found it. Added these two together, subtract from 180, so I got 56. Set up the law of sines right here, because now I have 40 over sine 56 equals x over sine 30. Okay? Cross multiply, and this is what you put in the calculator, and you get 24 meters. Alright, for 12, we're going to use the law of cosines because we have three sides, no angles. And remember, you get the longest side because we're going to look for the biggest angle first. So this is the one we're going to look for first, angle C, right here. And here is the setup, 9 squared plus 12 squared minus 20 squared, all over 2 times 9 times 12. So this is what you get when you simplify. This will give you a ratio. To get the angle, you do inverse cosine of this ratio, and you get this angle right here. Then I look for the next biggest side, or angle rather, so that would be angle B. So here is the setup for that. And that gives you this, and then you get inverse cosine so that you could find angle B. Okay? And to find angle A, you could use the law of cosines again, but you could also just add these two together, subtract from 180, and we get 1530. Okay? Number 17 is another law of cosines, except this one is not a side. This one, they give you, this is a side angle side, right here. No opposites. So since we have angle B, we could find side B using the law of cosine. So here's the setup. And all I did is I simplified like this number, that number. I multiplied here, then I combined these together, and I get 468 minus 32 cosine 48. Remember, these do not get combined. You just put them in the calculator as you see them. That's going to give you b squared, which is this one. Notice I put dot, 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 the ellipsis, because I'm not rounding. I'm going to take the square root of this long number from the calculator, and this is what you get. So having having side B, I can now find angle A by setting up the law of sines. Okay? Cross multiply. So sine A is going to give me this ratio. To get angle A, you do inverse sine of this ratio. And this is what we get. Now, I believe what I did is I didn't put in 13.38. I kept the original number, the one that we got from here. I know I rounded right here, but for the calculations, I kept the full number from the calculator. I didn't clear the calculator, I kept it. So this is what we get. For side angle C, since we have angle A and we have angle B, I just added them together, subtracted from 180. Okay, number 18. It's a word problem. This is the picture. The black numbers are the ones they gave you. So in order to use the law of cosines, I need the inside angle, the interior angle. So I know that this is 65, so the supplement would be 115. And here's the setup for the law of cosines. So again, this is squared, squared, and then these three multiplied together is this, cosine 115. I combine these two, which is here, and then I just put this into the calculator, and I didn't put the result of the x squared. After I got x squared here, from here, I took the square root to give me 615. Alright, 19 is an area formula. And because we are given the side angle side, I'm going to use this formula, the one that has 1/2 BC sine A. And I just replace the variables with the numbers and put it into my calculator, and I got this. Don't forget to write square units. For 23, we use Heron's formula because they gave us three sides. So you find the semi-perimeter first by adding these three and dividing by 2, and that gives you the S value right there. And then it's the square root of the product of the S times s minus 1 side A times s minus sine B times s minus side C. So here are the simplified numbers, and then you take the square root, and we get this. Okay, and that's it for the front side. On the back are all the identities, so I went ahead and I verified them, so I'm going to walk you through the steps. So for number 28, what I did is I worked on the left side, and I noticed that I know that you could say, oh, I'm going to factor this out, but I looked at it and it wouldn't get me to this. This is my goal. So what I did was I converted this to 1 over sine, and then I noticed that they cancel, so that gave me a 1 minus sine squared, which is cosine squared, and it's done. Number 30, I worked on the left side again, and what I did was, since I noticed that this side does not have any signs, I replaced this with 1 minus cosine squared theta. Distributive property, and you see it right here. I distribute it. Then I'm going to combine these two right here. So that gives me cosine squared theta plus 3, and I just switch the terms around so that it matches this side. Okay, for 32, I'm working on the left side. I'm getting a common denominator, which is this times this. So when you do that, this fraction gets multiplied by sine theta, so that's why we have sine squared. And this fraction gets multiplied by 1 plus cosine. That's why we have this one squared. So here is a common denominator. So in this step right here, I distributed this binomial and I combined the fractions. So now I have one fraction, okay, with the same denominator. And I notice that I have a sine squared and a cosine squared, so I put them together. That gives me 1. And I already had 1 plus 2 cosine theta, so 1 plus 1 is 2. Okay, so this is what we have now. I factored out a 2 from the numerator, so it's right there. There's that factor. And 1 plus cosine theta and 1 plus cosine theta do reduce to 1. And so now I have 2 over sine theta, which is 2 cosecant theta. For 34, I'm working on the left-hand side again. I didn't write it down, but it's the left side. So I converted these two to their 1 over sine, right here and here. Then I multiplied top and bottom by sine theta. So what happens is, when you multiply by sine theta on both top and bottom, sine theta over sine theta cancels, so you're left with 1. And then you distribute it right here, and you're left with sine theta plus 1. Okay? Now, my goal is to have a 1 minus sine theta in the numerator, and one of the strategies is to multiply by the conjugate of the numerator or denominator. So if you have a function plus or minus a number, this is what we're talking about. So here is the conjugate of this. So I multiplied, and I get 1 minus sine theta. Denominator is 1 minus sine squared theta. And so 1 minus sine squared theta is actually cosine squared theta, and this is, we got what we needed. Okay? 36. Left-hand side, again I converted this to 1 over sine, and I multiplied by the conjugate. So this one's similar to 34. So I'm gonna, the numerator, notice I just put together, there's a times right there. The denominator is 1 minus cosine squared theta. And this is 1 plus cosine theta over sine theta. And this becomes sine squared theta. Okay? And when you multiply these, you get sine cubed theta. So now we got what we needed. For 38, I worked on the left side, and I replaced this with secant squared theta. Then I divided the secant squared theta into the two factors. This one I converted to 1 over cosine, so this cancels. And so I've got 1 times secant theta, and we're done. Number 40 is very similar, I think. I factored out a cotangent theta from the left side, and then I'm left with this. This becomes tangent squared theta, and then I